Hila introduced us. We are both part of the NLP group here at Citi. And we're going to present you today work that we did on implementing different approaches for data augmentation. So just a few words on our NLP. A quick overview of what we are going to talk about today. We are going to say a few words about our NLP group and the challenges that, some of the challenges that we have. And then we will briefly talk about the data annotation process here in Citi. And then we will present you two out of several approaches that we use for doing data augmentation. And lastly, we will present you a model that we train on the augmented data and its results. So our main goal as an NLP group here at Citi is actually to facilitate and simplify daily basis tasks that bankers do. Much of the work is being done manually, and much of it is a very Sisyphic work, and we would like to help them and do it by doing it automatically and using some NLP tools. So just to put you in the context, Hila already mentioned it, but Citi is one of the biggest banks in the world. It is spread worldwide. It is a huge corporation. It has branches all over in almost every country. So for us as data scientists, especially as NLP people, this is a great opportunity because there are many business units, so there are many documents that are being stored and processed and created on a daily basis. So it's like a great potential of having really great and interesting and diverse data and doing some really cool stuff with it. Okay, so I will present you one of many tasks that we are dealing with in our group, and one of them is information extraction. Well, there are, like I said, many types of documents, and here we would like to extract certain relevant information for the bankers, and by doing it automatically. So I just have to mention that the data comes in very different formats. So some of the documents are a formal PDF. Some of the documents are written email or email correspondence. Some of the documents are very structured forms. So those tasks that may seem trivial to us as human readers can be untrivial or a bit tricky when we're trying to automate them. So I will show you now an example of one of the documents that we have to work on. Of course, it is blurred because this is a bank and I can't show you the data itself. But a document can contain many pages, and we have to search for certain relevant information. For example, we need to find the company name, or we need to find the company address, or we need to find the date. But usually we don't want to just find a date or a company name or an address. It should usually come with a certain context. So how do we do that? Well, this is the very naive and basic pipeline when we're trying to solve an NLP problem. So we need the label data, then we can do just a few pre-processing methods on it, and then we can just put it as an input to one of the greatest state-of-the-art models that exist today, and we should be happy. But as you're probably guessing, it is not that easy. Well, the first bottleneck that we're tackling is in the first stage, where we actually need to get the data. So as I said before, there is tons of data in Citi, but Citi is a bank and most of the data is confidential, and so we have very limited access to it. And even when we do have some access to some of the data, we need domain experts to annotate it well and to give us the correct labels. And this resource is also very limited. Okay, so just a few words about the data annotation process. Well, we are asking usually the domain expert to spend as much time as they can, which is usually not a lot, by doing some annotation on the data. And then we're using data augmentation. That actually the goal is to make this small data set larger and versatile enough so we can make a robust model, and then we just give it as an input to the model that we're using. We train it, and then we can use some methodology that's called active learning. So this is a methodology that helps us pick the relevant new samples that we would like the domain expert to focus on, and because we want to optimize the time that they are spending on it, and then we can just do this cycle again and again. Okay, so what data augmentation really means? Data augmentation it's a method that we're using for creating a larger data set from an existing data set, but by either modifying it or by creating a new synthetic data. But when we're doing that, we should keep in mind that the main goal is not just to make the data set larger, but we need to make it as versatile as possible, and we would like to keep the same high quality of the labeling, and also we would like to keep the same original meaning, so the labeling won't change. Okay, so now to the interesting part. How did we do that? So again, we will present two of the approaches that we're using here. The first approach is a textual augmentation, where the input is actually a sentence. It's a plain text. Okay. So I'm going to present now 4 of the augmenters that we've implemented, and actually each augmenter has a different responsibility. It uses different methodology for doing the augmentation, the modification. So the first augmenter, the resource augmenter, is an augmenter that we give it some file that contains any alternative value for a certain entity. So that means that in a sentence, we would like to replace certain words that have certain feature. In this example, we would like to modify all words that represent animals. So we give the augmenter an input file that contains list of all animals' name, and it just picks randomly any animal name and place it and replace the original words.
But it can change the meaning of the word. The sentence might change.
We change the word, but still we want to make this is the whole point. We want to make new sentence but we don't want to make the same sentence. So we decide how much we would like to change it. I mean, this is why this is a resource file. You can decide which animal list, for example, you would like to.
Let's say he was fast as a rabbit, and change it to he was fast as an elephant.
Yeah, but again, it depends on what you're trying to do. Yeah.
If you're doing it randomly, you can.
No.
You decide what is the vocabulary for it.
Yeah, exactly. And besides doing it randomly, just one of the methodology. There are other implementations, but this is the most naive and simple one. Okay, so another augmenter that we've implemented here is the date augmenter. In this augmenter, we just take the part of the text that represents a date. So here is the 14th July 2019, and we just replace it with a random date format that we gather from all kind of documents that we've processed. So we just pick a random date format, and we generate a random date. So it can be, for example, only the year, like 2015, or it can be a date that contains words and numbers. The next augmenter that we're using here is the mask language model augmenter. This augmenter uses a BERT-based language model, and again, we decide as user what words with what feature we would like to replace, and then so we can decide, for example, that in the sentence we would like to replace all nouns or all verbs or all other words that have specific features, and we just mask them, put it as an input to the language model, and then we get the predictions that by which we actually replace the original word. So, for example, if we will replace here the word awesome, we can get from the masked language model the word it's amazing, or it's fantastic, or it's great. Okay, and the last augmenter that I'm going to show you here is the random noise augmenter. In this augmenter, we actually use the text attack implementation. Text attack is one of the open source libraries that exists. And this augmenter, what it does, it just enters randomly typos, common typos from keyboards, or just drops randomly one of the characters in the sentence. So you see that from the word what, it drops the A, or from the word create, it drops the T, and here it drops the U. Okay? So how actually this whole process goes, we decide which augmenters we would like to use, and in which order. And so given an input sentence, the whole pipeline actually finally outputs a list of different sentences that contain, each sentence contain different combination of modifications that were done by the augmenters that we've chosen to use. So if we are using now the resource augmenters of the animals that I've shown you before, and also the MLM augmenter, so one of the output can be this sentence where the word fox was replaced by wolf, and the word dog was replaced by cat, but also the MLM augmenter added another modification to the sentence where it replaces the word jumps by climbs. Okay, and this is another example where one of the outputs would be only the output of one of the augmenters. Okay, or we can get different values from these augmenters. So I will show you now a real life example. So we have an input sentence that contains a name of a financial institution, American National. You see that sentence, the company name is American National Bank. The date of announcement is 13 July 2020. So we would like to use the date augmenter and to replace the financial institution by any other financial institution from a given resource that contains names of all financial institutions, like we did with the animal case. So one of the outputs would be the replacement of the name of the institution and the replacement of the date. And another output sentence would be a sentence that also contains the modifications that were made by the MLM augmenter. So you see that it modified the word date to time and the word announcement to issue. Or we can have also the modification that is made by the random noise augmenter, that where he entered the typo in the announcement word, or dropped the E in the D word, and added some more typos in the date. So finally, what we are actually getting in this pipeline, we are giving it an input, one sentence where we can actually label each word with different features, and we can decide, we can configure which augmenters we would like to use, and on which feature we would like it to work on, to do the modifications, and then the output would be a list of different sentences that each of them contains different combination of augmentation. Okay, and so just last word. Today there exist several open source libraries that do data augmentation. We can use text attack for data augmentation, or there is also NLP aug, and there are several others. Okay.
Hi everyone, my name is Eylon. So I will continue to talk about layout data augmentation. So this is very similar to text augmentation, but this time we have another modality, which is the layout. So what do we mean by layout? So imagine we have this document. Now this document is a scanned image, so it's no text, right? We have to process it in some sort of way, like OCR, as we can see. And then we have the text with the layout. So what is the layout? Actually, it's only the bounding box around each one of the text box. Now pay attention that you don't really get the text as plain text or spans or something nice. You just get dots over the documents. You don't really know, for example, that program budget code is a span. You just get program, code, and budget, right? And you can also have it splitted, like budget is budget, and the OCR doesn't know that. So we have many complications, and we see that in a minute. So what we'll have is text and bounding box, which is the OCR token. Okay, so this is a real example. Again, this is a document which is blurred because of the confidential. You know that? So actually what we see here is 3 types of data we extract. So the first one is key values. We have, for example, here name and the value of the name, some company name. We have checkboxes, and we also have fill-in text, which is paragraph with lines, and the clients just send us PDFs with signs or something like that, or filled in country name or date or stuff like that. So how does the pipeline looks like? Quite reasonably, you get a PDF for the image. It's scanned image. And then we process it using OCR. We call it OCR++ because we have our own custom extension. For example, we extract lines, we extract tables, we extract images, and some other kinds of stuff. And then we can move to the information extraction. Now, the data augmentation comes in between. So instead of working on the text level, we work on the text level with the layout combined. Now, we must produce stuff that looks real. And we cannot lie. So, for example, what you mentioned with the elephants, now we have another complication because it's not only the text that can be coherent. We need also the layout to be coherent. So, just to present some of the complexity of the task itself of the information extraction, the first one is the horizontal context. This looks quite trivial for us as humans, as the key is on the left and then double dots, and you have the value on the right. But sometimes it's a little bit more complicated. For example, here you see vertical context, and why is this different from this one? We need to distinguish between the two. Another example would be the multiline. So multiline is key and value, but we need to understand that it's not only key and value one against the other. It can be multiline. Also, the key can be multiline. There are plenty of really weird stuff that you see in documents, and we just accept them because we are humans, but the machine cannot really process them quite well. Another one, and there are many more, but this is just to get you into the details. So checkboxes. Checkboxes are quite complicated. You can have them multiply checked. Some are empty. You can also have extra data. For example, here you have another text that can be free-filled by the client. So many complexities, but this is the task. So how do we solve that? We want that augmentation to work not only on the text, but also on the layout. So what we do is take a real example. This is not a real example, but I had to show you something in higher resolution to understand how it looks like. So for example, if we zoom in on this portion of the document, we have here a shifted version. So we have many types of shifts. For example, we have shifts between the key and the value, which can be here a little bit tighter. We can also have the values spreaded differently, and there are many creative stuff that our clients like to insert for us. And also, there's a shift here, if you see the vertical shift. Now, this is not trivial again, because the account SID is founded next to the company LTD, but we know that this is not true, right? So it's quite complicated. So the first one is shift. Another one which we present is the resizing. So because it's scanned, sometimes the font a little bit looks different. There are noises, there are resizing, skews, all kind of that. And there are many more. For example, you have noise in OCR. Sometimes the OCR just produce things that are not true. Can be also many lines over the scanned. So it doesn't really look always pretty. But this is how we augment both the text and the layout complications. So eventually we have something like that. We take only a few. 100 is quite an exaggeration. We have only like 10 of them or something like that because we don't need to frustrate our people. And then we have only a few of them and we make them thousands, but still diverse and coherent both textual-wise and layout-wise. And we have a huge data set to train some model on it. So this is the data augmentation we use. And just in a word, to get you curious, and if you want, you can ask questions afterwards. So what models do we use? So just if you want to get a little bit more familiar with the models. So BERT, I'm guessing most of you already know. It accepts text and the position in the sentence, what we call a one-dimensional positional encoding. And then you get contextualized vectors. So this might look already known for us. What we need now is a two-dimensional positional encoding. And this is the main difference between BERT and layout LM. And from that, we also progress to VBERT grid, for example. It's only one out of many, which also combine the modality of the image. For example, lines, tables, checkboxes, stuff like that. So that's only in a brief about the models. And some results. So this is only a single task. We have many of them, and this is also a work in progress. But just to show you the power of data augmentation, even a simple one. So when we use it without augmentation on less than 100 documents, we get quite poor results. We cannot be satisfied by 90. We need like 95, even 100 sometimes, even if it's overfitted, because it's a bank. You cannot do mistakes. So before augmentation, it's quite low, but when we add some augmentation, it looks much better. And just to show that we don't really overfit to something specific, we also show results of out of domain. So if you take the same model trained on the first data with augmentation and take to inference another data set, we still get quite good results. Now, if we want, we can also improve that. We just look at the other data set and adjust that with another data augmentation. Now, data augmentation is quite simple, so it works for our best.
What is the metric that you're showing here?
So that's F1 of named entity recognition. It's one of the tasks, and yeah, thanks. It's up above. Okay, so to summarize, we showed you only a really tiny portion of our ecosystem here. So we have many challenges. We don't have access to all the data, and when we have only little of that. We design data augmentation as one of the strongest strategies next to the active learning, which we don't talk here. And eventually, we just improve our models to make products which achieve 95, maybe more, because we cannot have less than that. So that's it. Thank you.